Hi everyone. In my today's session, I'm going to discuss about a creational design pattern called factory design pattern. Okay, so let's start with this. So, what is a factory design pattern? Okay, according to the Gang of Four, who basically written a book on three categories of our design patterns, what they say is the factory design pattern states that a factory is an object which is used for creating other objects. So take for example, if I have a factory of car, it will create products like car. Okay, so the car cannot be of one model, it can be of different models. Okay, so that's what a factory is, an object, and that factory we use to create other objects. Okay, so in technical terms we can say that a factory is a class. If we come to the object oriented paradigm, in technical terms, we can say that a factory is a class with a method. Okay, and that method will create and return different types of objects based on the input parameter it received. In simple words, if we have a superclass and n number of subclasses, and based on the data provided, if we have to create and return the object of one of the subclasses, then we need to use factory design pattern in application design. Okay, so in simple words, so let's see an example. Okay, so notification. Okay, notification is my base class, or I can say my base interface basically. Okay, so what are the various types of notifications are available? Okay, we can create a SMS notification to your mobile, we can create an email notification for your email account, and we can create a push notification basically. Okay, so you can implement different kinds of notification, but the concept of notification is basically generic. Okay, so your notification acts as a base class or base interface, and from that interface we basically implement the concrete classes or concrete objects basically. So like from the notification, I have created a SMS notification, I have an email notification, and I have a push notification. Okay, and if you see this class diagram, it's very simple to understand. And then comes, I have a notification service. My notification service is basically a main program. Okay, so if you compare with C sharp or Java programming, it is the driver class or the main class which basically runs your program. Okay, or you can call it a consumer program basically. So notification service which has a main method, and that main method will invoke a class called notification factory. Okay, so if you see the design pattern that we are discussing about a factory design pattern. Okay, so what this notification factory is going to do is it will be contain one method called create notification, and based on the input passed to this create notification, this method will decide what kind of subclass to create, what kind of subclass object to create. Okay, so notification factory creates any one of these based on the input provided to create notification. Sorry guys, I missed the parameter here, but there should be a parameter. Okay, which will tell what type of notification I need to create. Okay, so after going through this class diagram, it is very evident that this statement that we gone through just few moments ago, in simple words, if we have a superclass or a base interface, I can say, and n number of subclasses, n number of subclasses inherited from that base class or base interface, and based on the data provided, if we have to create and return the object of one of the subclass, then we need to use the factory design pattern in application design. And here is the example in front of you. Simple one, but pretty straightforward and makes sense. So let's go through when to use the factory design pattern in real-time applications design. Okay, so it would not be a good programming approach to specify the exact class name while creating the objects by the clients, which leads to tight coupling. Okay, now just take an scenario. I'm going to take you through an programming example, guys, but for the time being, it is always not a good practice to directly create objects in your software development, especially if we are working on enterprise grade software. Trust me, guys, this is strictly prohibited. Okay, no code reviewer will review or approve your pull requests or the code review request you send to them if you follow this kind of approaches where you directly instantiating an object by using new operator. Okay, so it would not be a good programming approach to specify the exact class name while creating the objects by the clients, which leads to tight coupling between the client and the product. Okay, so basically you should not establish a tight coupling between these two classes. Okay, the consumer class and the factory basically, or the service provider, you can say, basically who gives you that object. There should not be a tight coupling. Okay, to overcome this problem, we need to use factory design pattern in app design. This design pattern provides the client with a simple mechanism to create the object. So we need to use the factory design pattern in app design when the objects needs to be extended to subclasses. Okay, it is pretty much sure, you are pretty much sure that you have a class of objects which basically extended from a base interface or from a base class. Okay, there is some generic feature which can be encapsulated in your base class or interface, and then there will be specialization by the various subclasses. Okay, so the object needs to be extended to the subclasses. Okay, classes don't know what exact subclasses it must create exactly. For example, if you see this consumer, our main class or our main method, you can say. Okay, when my main method doesn't know what kind of object to create, whether SMS notification, email notification, push notification, no, it doesn't know anything about it. Okay, but it knows that there is a factory and there are a n number of subclasses inherited from a base interface or a base class, you can say. Okay, so in such scenarios, yes, we must make use of factory design pattern. Okay, the product implementation going to change over time and the client remains unchanged. Very important statement, guys. The product implementation going to change over the time and the client remains unchanged. Okay, so today I have only three types of notification. Tomorrow, if technology advances, if there is advancement in technology, and if there are new ways of sending notification through AI, artificial intelligence, or any other techniques, then there will be increase in the number of subclasses this particular notification system have. Okay, so in such cases, basically you can go with factory design pattern. The product implementation going to change over the time and the client remains unchanged because my client will always deal with the base interface, that is I notification or the base class reference variable notification. Okay, it is never going to worry about what concrete class object will be put into this base class or interface reference variable. Okay, so the client is always unchanged. It doesn't worry about what kind of object you are going to put. We know the fact that all these subclasses inherit or implement a base interface, and using that base interface reference variable, you are going to trigger the various notification functionalities like notify user. Okay, so when this is the design, when this is what you are sure about, then go ahead with implementing factory design pattern. Even if your application involves, sorry, even if your application evolves, okay, even if there are n number of new subclasses have been created for this notification, but still your notification client and the factory will remain, sorry, your notification class, which is basically a main class or a client, basically a client application, will remain unchanged and you can do whatever change over here and here. Okay, so limitations of factory pattern in application design. Okay, now this factory pattern comes with some limitations also, guys. So let's understand what are the limitations. If we need to add any new product, that is new notification type, then we need to add a new if else condition in the create notification method of notification factory. Yes, whenever you introduce a new class, okay, for that class you introduce a new parameter which will tell you have to use that new class, and yes, you have to put a if condition inside this notification factory class. Okay, so yes, agreed, this violates the open closed principle, the open closed design principle. Okay, your classes should be open for extension but it should be closed for modification. But what happened here, you are basically modifying an existing class by adding various if else conditions. Hmm? And then, yes, we also have a tight coupling between a factory class and the product classes. Yes, because your factory class I will show you in a moment now how this setup will be done. Your notification factory class, okay, basically have a create notification method, and inside this create notification method, based on the input parameter sent, you are basically creating object of these subclasses by you directly making use of those class names. That's why they are mentioning we also have a tight coupling between the factory class, that is the notification factory, and the product classes like SMS, email, notification. So that's all about factory design pattern. So let me show you the example, same example I have taken. Okay, so I have a base class, or because I'm working with C sharp, okay, object oriented programming language, I'm making use of interface to represent that base interface. Okay, so I have a base interface called iNotification, okay, and which has one method, that is notify user. Okay, so this contract or this interface, basically iNotification performs one operation, and that operation is called notify user. Now it is up to us how we basically create concrete classes, and those concrete class implement this iNotification interface, and how they provide implementation for notify user. So take an example for SMS notification. Public class SMS notification, okay, implements iNotification. Okay, now in order to send a SMS notification, what I need a phone number, right? See how the implementation is changing at the subclass level now. So in the constructor parameter, what I'm going to do is I'm going to receive the phone number. Okay, I will set it to my class member. Okay, now I will implement the notify user, which is coming from my notification interface, and in my case public full notify user. Okay, so what I'm going to do here, I'm going to write the code. I'm going to provide a implementation which basically deals with sending SMS to your mobile phones. Okay, so I have not put the actual code here, but for understanding purpose, just I have put output statement, that is console.writeLine SMS has been sent to phone number this. Okay, see, so it's up to the subclasses how they provide the implementation for these operations provided by your base interface, or you can call the interface basically. Same you can implement with the abstract base class also, but nowadays it is a best practice to go with interfaces, because interfaces define the contracts basically. Okay, same applies for email notification, but here in order to send an email notification, I need an email ID. So that's why this constructor will receive an email ID as a parameter, and then my notify user method basically contain a logic or a code implementation which basically connects to a SMTP client, okay, or any third-party email service provider, okay, and then uses this email ID and then sends notification to his email account, his or her email account, okay. See, this is the email notification. This is the email type of notification. Then comes push notification. Here I need the push notification account. Same stuff. I will get the account details here for in order to send the push notification. I will construct the push notification client object over here, or using a third party library, and then I will send a message or send a notification to that particular account. Pretty simple, guys. Okay. So now I will go towards my notification factory. Okay, public class notification factory, which has only one method as per our design over here, which is create notification. Okay, so create notification, which receives basically the notification type. Okay, yeah, so which receives a notification type and then a user ID. Okay, guys, so I will explain now. Can you see, it is basically your client don't know this is your client application or main program. It doesn't know which particular notification to send. So how it decides which notification it has to send basically? Okay, so what it is going to do is it will it will receive the input from the user. Okay, this driver application or the client application is basically a GUI application which will ask user what kind of notification you would like to send, and it will present with a drop down. Do you want to send an email notification, SMS notification, push notification? Based on the selection made by the user, it will take that value and it will call the notification factory. Okay, it will construct the notification factory first, and then on the notification factory it will call the create notification method for the selected input. Now I want a SMS notification, that's why I'm sending the parameter as SMS. And if you go to the implementation, see here, when the parameter type is SMS, yes, I'm going to create a SMS notification object. Okay, guys, most important stuff to remember is, see the return type of this create notification. It returns I notification. Okay, it is not at all returning any of the concrete class type here. It is not going to sorry, it is not going to contain the concrete class name in this method signature. It will just contain the I notification. Okay, now as we are aware in object oriented programming, okay, a base class reference variable or an interface variable can point to any of its subclass object references. That's why if you put I notification here, yes, I notification object reference variable can contain a SMS notification, it can contain email notification, it can contain push notification, because all these three classes basically implement I notification interface. Okay, so well, that's all set. So I will come to the client application as I already explained. Okay, so what I did, I created a notification factory, then I read from the user what kind of notification he or she wants. Okay, in my case, he or she said, yes, I want a SMS notification. I passed the SMS notification and I received the SMS notification object here. Okay, so what I'm going to do on that SMS notification object, simply I'm going to call SMS notification dot notify user. That's it. It will send the SMS notification to the user, and see the type written by create notification as already explained. It's a I notification. Okay, and you are no need to worry about whether I'm calling email notification, push notification, or SMS notification. This is already taken care by your factory itself. It's simply based on the input provided by you. It simply constructed the required object and it passed it to your client application. And your client application will remain unchanged, because your client application always deals with I notification interface. That's it. Very simple. Okay. Now, tomorrow, if you introduce y- further n number of subclasses. Okay. Today I have email notification, SMS notification, and push notification. Tomorrow, if some more notification techniques comes, then simply implement that notification technique by implementing I notification interface and provide the implementation. Okay, your client will always remain unchanged. Okay, you just pass the kind of notification you want to pass. Okay, and you will receive that object, and simply you call notification, that is SMS notification dot notify user. Rest everything will be taken care by the object, the notification object itself. Okay, you are no need to worry about anything over here. You can call it just a notification. That's it. Yeah, so everything taken care by your factory itself, your notification factory, or I can call it factory design pattern itself. Okay, so this is what the factory design pattern is basically. I hope you people understood the crux of this. Okay, and I have already explained the disadvantages also. Let me highlight once again. Okay, see, if we need to add any new product, then we need to add a new if else condition in the create notification. Can you see here? Tomorrow, if I come up with a new notification, then I have to add one more if else or a case condition. In my case, I'm making use of switch, but it doesn't matter. You are using a branch. Okay, so some notification dot xyz kind of notification, you can say notification type dot xyz. Okay, see, every time you have to keep on adding code here. Every time you have to add a if condition or a case condition whenever a new class is introduced. Second disadvantage, we also have a tight coupling between the factory class and the product classes. Yes, see, this is my factory class, these are my product classes, and can you see the tight coupling? I'm directly making use of new SMS notification here. Can you see this? This basically constitutes a tight coupling between these two classes. Okay, so this is the disadvantage with this factory design pattern. But yes, There is an advanced version of this particular design pattern which is called abstract factory, where we will get rid of these two limitations of factory design pattern. Okay, so I'm going to explain that in my next session. And yeah, that's it for today. I hope you people understood the notion of this design pattern, and yeah, it will help you in your day by day design activities of your enterprise grade software applications. Thank you for listening, and have a nice day, guys.